Pause the video to write down example 1 and 2 in your notes. How do you solve one-step equations? The ones we're going to practice here in 1 and 2 are going to be ones where we need to use inverse operations for adding, another way to say that, a positive, and subtracting, another way to say that, a negative. So remember, what is the opposite of a positive or adding? What's the inverse operation? Subtracting. What's the opposite of subtracting or a negative? What will undo subtraction? Addition or a positive. Looking at example 1, negative 40 equals n plus 18. Our job is to maintain equality. The goal is to find the value of that variable, to get it by itself. What's connected with that variable? This positive 18. What will undo that positive or that addition? Subtraction. So to maintain equality, we need to subtract 18 from both sides. Positive 18 minus 18, that leaves me with 0. N plus 0, I can just write that as n. Negative 40 minus 18, that leaves me with, use a calculator if you would like to, negative 58. I like to see that variable coming first once I solve for it, so n equals negative 58. And then before we say we are done, we're going to use substitution. Take negative 58 and plug it in for n. Negative 40 equals, I'm just rewriting and putting negative 58 in for n. Is this number sentence true? Does negative 58 plus 18 equal negative 40? It does. For example 2, pause the video, do this one on your own, then come back and check your answer with mine. I got in example 2 y to equal 7. If you didn't get that, pause the video again and compare your work with mine. Before we say, yeah, we're all done and ready to go to example 3, let's use substitution to plug 7 in for y. Negative 10 plus 7, does that equal negative 3? Yes, it does. Pause the video to write down example 3 and 4. Looking at example 3, we have negative 21 equals x minus a negative 5. The very first thing that stands out is the take away a negative. That means this is really x plus 5. What do you mean by that, Mrs. Kluver? Again, because you are taking away the negative. Remember, when there are two negatives touching each other, that really means plus. So we have negative 21 equals x plus 5. We need to maintain equality. Our job is to figure out the value of x, get it by itself. We need to get this plus 5 out of here. What are we going to use to do that? The inverse operation. So minus, and we're going to minus a 5 to both sides to maintain equality. Positive 5 minus 5, that gives me 0. I'm left with just x on the right equals negative 21 minus 5. That's going to give me a negative 26. Before I say I'm done, I'm going to flip this around. I like to see my variable first. I'm going to use substitution. I'm going to plug negative 26 in for x. So we have negative 21. Does that equal negative 26 plus 5? Yes, it does. And again, something unique with this problem was it was take away a negative 5. So we had to change that first because that really means plus whenever you're taking away the negative. The positive is default. Example 4, pause the video, you do that, then come back and check your answer with mine. With example 4, I got m to equal 47. Something unique with this problem is you see that you're taking the term m and you're adding it with a negative 31. You might go, well, this is addition. Shouldn't you have used subtraction, Miss Kluber? If I were to minus 31 instead of plus, this would not be out of here. It would give me negative 62. So just because this was an addition equation, notice we didn't use subtraction to undo. We had to pay attention to the sign that was in front of the term that we needed to get out of the expression. Let's check using substitution to see if we solve correctly. So we have 47, we're putting that in for m, plus a negative 31. Does that equal 16? Yes, it does. Let's go to the next two examples. Pause the video to write down example 5 and 6. How do you solve one-step equations? Now we're going to be dealing with multiplication. Therefore, we need to use division to undo them. We're also going to have division equations. We need to use multiplication to undo them. Looking at example 5, negative 6n equals negative 114. Maintaining equality, my goal is to get the value of n, to get n all by itself. Therefore, I need to get that negative 6 off of there. It's negative 6 times n, so I need to use division. And I'm going to divide by negative 6 because that coefficient is attached to n. The negative needs to come with. Negative 6n divided by negative 6, that gives me 1n, which I can write as n. Negative 114 divided by negative 6, that's going to give me, use your calculator if you'd like to, 19. Now before I say I'm done, let's use substitution. We're going to take 19 and plug it in for n. Negative 6 times 19, does that equal negative 114? Check it on your calculator. I know right now my signs are right because this is a negative, this is a positive, therefore my answer would be negative because the signs don't agree. And when I take 6 times 19, I get 114. So yes, I solve correctly. Pause the video and you try number 6. Notice this is a division equation. What are you going to have to use to undo the division? Multiplication. Be mindful, remember when we did our review lesson 5.0, be mindful of how you show the multiplication that's undoing the division. We work out instead of working down. When I solve for h in number 6, I got the value to be negative 91. Negative 7 was attached with h. My goal is to find what the value of h is, to get it by itself. So how did I get this negative 7 out of there? I did the inverse of dividing, so multiplying by negative 7. There's that diagonal. In lesson 5.0, I showed you how this gave me one of my variables. If I multiply by negative 7 on the right, I need to multiply by negative 7 on the left. Negative 7 times 13 gives me negative 91. Let's substitute negative 91 in for h. 13, does that equal negative 91 divided by negative 7? Well, my signs agree, so I should get a positive. Use your calculator. 91 divided by 7, do you get 13? Absolutely. We solve correctly. Let's go to examples 7 and 8. Pause the video to write down examples 7 and 8. Looking at number 7, we have m divided by negative 9 equals negative 21. Maintaining equality, meaning I want to keep everything balanced as I work throughout. Since it's division, I'm going to use multiplication. What number am I going to multiply both sides by? Negative 9, because it's attached to the variable. It's part of the expression. So I'm going to take and be very mindful of how I show that multiplication. I have my diagonal. This gives me 1m, which I can write as m, equals negative 21 times negative 9. My signs agree. It's going to be a positive. Type it in your calculator. What do you get? 189. Before we move on, let's make sure we solve correctly. Let's go ahead and let's take 189 and substitute it in. 189 divided by negative 9, does that give us negative 21? You bet it does. Pause the video, you do number 8, come back and check your answer with mine. When I solve for x in number 8, I get it to be negative 3. Remember, negative 45 is attached with the x by multiplication. When I am using division, I need to take the whole coefficient, which is negative 45, not just the 45. Be mindful of that. That's something that's new with this lesson. So I'm going to take negative 45, plug it in for x. So 135, does that equal negative 45 times negative 3? Yes, it does. Let's go ahead and let's do example 9 and example 10. The next two examples are going to be real-world problems, where we're going to have two jobs: to write the equation to represent the real-world problem, and then to solve, to find the solution, the value of the unknown. Zion's Apple Watch costs $430 less than his iPhone. If the Apple Watch cost $399, what was the cost of the iPhone? We have two tasks. We need to write the equation to model that situation and find the value of the unknown. What are we being asked to find in this problem? What was the cost of the iPhone? Let's answer that question in the form of a sentence. The cost of the phone was blank dollars. Marking the text is allowing us to see our unknown, our variable in this problem, which is the cost of the iPhone. Let's let C represent the cost of the iPhone. That's going to be a number in the problem which we don't know yet. Let's go line by line and look for key words, phrases, and important numbers. Zion's Apple Watch costs $430 less than his iPhone. Less than tells me to subtract. The cost of the Apple Watch, $430. Less than his iPhone, that's our unknown number, cost of the iPhone. Let's let C represent that important unknown number. If the Apple Watch costs $399, what was the cost of the iPhone? So we know that the Apple Watch has a total of $399. That's what that cost right there is telling me. That's my equal sign. Let's go ahead and let's translate. Zion's Apple Watch costs $430 less than. This whole part right here, 7th graders, are turnaround words. It needs to come after his iPhone, which we're letting the variable C represent. So C minus 430, we know that that equals 399. There is our equation which models the situation above. It's a one-step subtraction equation. We need to use addition to get this minus 430 out of there, 430 out of there. So let's go ahead and let's add 430 to both sides. On the left, I'm left with C. And on the right, what's 399 plus 430? 829. The cost of the iPhone was $829. We wrote the equation that models the situation. We solved for the unknown. Something that was really helpful was using our marking the text strategies. First, boxing in our question, and then answering that question, because that allowed us to see that we were trying to figure out the cost of the phone. That was our unknown, the cost part. Our next example is another real-world problem where we need to come up with an equation to model the problem, find the value of the unknown. There are a dozen pens in each box. If there are 288 total pens, how many boxes of pens are there? Let's use the strategy of marking the text to help us figure out this problem, where we need to write the equation and come up with the solution. What are we being asked to find? How many boxes of pens there are. So let's start by answering that. There are blank boxes of pens. We now know that our variable is going to be referring to boxes. That represents a number and we don't know what that number is yet. Let's go line by line, look for key operation words or phrases and important numbers. There are a dozen pens in each box. Each box. There, repeated addition is going to tell me to multiply. Dozen pens. A dozen is another way to say 12. If there are 288 total pens, so we know that there are 288 total. That total right there is my equal sign. How many boxes of pens are there? Let's go ahead and let's translate. There are 12 pens in each box. This box right here is my variable. Let's let B represent that. So it's going to be 12 times B. Box is referring to an unknown in my problem. And in math, we use a variable to represent a number that we don't know yet. There are 12 pens in each box. We know that there are a total of 288 pens. This equation will tell us how many pens are in each box. It's a one-step multiplication equation. We need to use division. We're going to divide both sides by 12. 12b divided by 12 gives me 1b, which I can write as b. 288 divided by 12 gives me 24. There are 24 boxes of pens.